Welcome everyone to the fifth segment of the Forest Products Society monthly webinar series, Forest Products Insight. Each month, Forest Products Insights will welcome a guest speaker sharing their research, technical expertise, and experience to a live audience. The series will take place on the third Wednesday of each month and will feature a new guest speaker from various industry areas. The event will be an open conversation where your questions can be answered and ideas can be shared amongst peers within the forest products sector. Please feel free to enter your questions into the chat box at any time, and we'll also have some time at the conclusion of the presentation for oral questions as well. If you're not an FPS member, we would invite you to learn more about FPS and consider membership in our organization. Thank you again for joining us today. We look forward to an engaging conversation, and thank you for your support of Forest Products Society. Today's speaker is Dr. Brian Vai from Auburn University, where he serves as the Regents Bank Professor of Forest Products and is currently the Director of the Forest Products Development Center in the School of Forestry and Wildlife Sciences. He recently took on the challenge of becoming Editor-in-Chief of the Forest Products Journal and has worked with his faculty and deans to start a new undergraduate curriculum called Sustainable Biomaterials and Packaging. Dr. Vai has worked at International Paper and Louisiana Pacific corporations in the area of wood quality and wood composites, respectively. As director of the FPDC, he works closely with industry for economic development and commercialization and has 2 patents to use soy flour, and wood adhesives. So with that, without any further ado, I'll turn it over to Brian, and we'll, again, please enter any questions into the question box, and we'll have time following the presentation to answer those and any additional questions that you have. So take it away, Brian.
Okay. All right, let's see here, share screen. Can you see my screen?
We've got it, it's not the full screen version yet. There we go.
Okay, thank you for having me. I'd like to also throw out a thank you to Will Hand and George Ching. Will Hand's on this call, and he was one of the inventors of one of our patents here, and there he is waving his hand, and George Ching is in there somewhere, and he helped do a lot of work on this project too. I also have quite a few grad students and postdocs currently working on it, so I didn't see that they had logged in, so I'll just skip that for now. But just a little bit of my background. So, I used to work in industry myself. As Chris mentioned, I worked at Louisiana Pacific in particular. As you know, they make a lot of various engineered wood composites, and so 7 years in industry in the manufacturing part, dealing with R&D with International Paper and Louisiana Pacific. So I like to reiterate that, even though Chris mentioned it, because we try to meet the needs of the end consumer. And so with that business background, even though now I'm a professor, that always helps us to sort of focus, what we think is important, which is usually quality improvement and cost reduction. Keeping in mind that we're not going to discuss prices or anything today, which would be a no-no. This particular presentation will cover from particle all the way up to veneers and everything in between that we've looked at least. And so that's what we'll cover today. And the idea is to take soy flour and mix it in with PMDI and figure out a way to drop this into a plant so that it's practical and doesn't have additional capital expenditures. So why are we looking at soy? And I like to highlight pre-COVID, it's still cheaper. Soy is still cheaper than MDI, but it looks like the prices of both are swinging around. But pre-MDI, or pre-COVID rather, the cost of soy was 1/3 of that of MDI. It's still a lot cheaper than MDI, so there's still value there. For the particle board end, as we talk with customers in the particle board industry, formaldehyde emission reduction is important to their industry. And I'm not going to get into the debate about the science of formaldehyde and those things, but just that companies are being forced to look at this for whatever reason, whether it's right or wrong. People are looking at that, and because formaldehyde, if it is emitting, it's can be hazardous to human health. Soy increases the cold tack of MDI. That's another issue that the particle board industry is looking at. And so for those of you not familiar with cold tack, basically If you think of particle board and you think of the line shaking as the conveyor belt is going along, then you can imagine the particles are falling off because the tack is not good enough of that MDI alone. So adding the soy flour helps to sort of hold those particles together as the conveyor belt is bumping along. So those were some of the quality issues that particle board has told us about. And then for Orient strand board, what we found over and over again in the lab and with some preliminary trials in industry is that when you take the soy flour, it reacts with the MDI and it actually improves the moisture durability. So it actually improves the thickness swell and the edge swell and those kinds of things. This is an important novelty, I think, because soy flour tends to be not like water. And so by cross-linking it with MDI, we sort of remove that weakness and turn it into a strength. And also companies are in the desire of greening their adhesives. And so this helps to do that. We've actually ran a couple of commercial trials now in an MDF plant, and I can't really tell who that is, and I'm not giving detailed information either. So just to say we've ran 2 commercial trials in an MDF plant, and so each time, one time 1.5 hour trial, another one 4-hour trial. So we're going to run another trial in the near future. Hopefully that'll be even longer. And so our objective with these trials is really to see if we can transition over from a lab scale to a mill trial scale, and we've been very successful. I would consider we've had no operational issues so far, and our water and absorption and strength properties tend to be comparable, and in some cases there's actually improvement in properties which I can't talk about, and in some cases I probably don't even know what those improvements are. Only the company may know that. During our first trial, we got rid of this during the second trial, but I wanted to point this out. You know, you see these specks, if you can see where my mouse is circling these specks here. And so if you don't mix the MDI and the soy flour, homogeneous mixture, then that can be an issue. And so that's really what we've been focused on ever since Will Ham was here, is trying to figure out how to mix this stuff and do it practically and get it inside the product. For the trials, we were able to successfully premix in totes. You'll notice it says viscosity increases with time, so it thickens over time. So, you know, you can't let it sit overnight. And so if you do, it's not going to work the same. And so that's a constraint that has to be considered. Basically, both trials have worked, and so we're working closely with the MDF industry. One thing is that we probably, for this technology, we need to use an inline liquid solid mixer. So we found these units that are available in the food industry. It's just a matter of transitioning over to the forest products industry. So one of the things we found was that actually getting the flow in there, the flow of our stuff was less than what the food industries, or what the wood industry rather, is used to seeing. And so we're just trying to figure out how to get the manufacturer to make it where it flows at the correct rate for us. So not a big deal. Another value that we found that we weren't really looking for, and this is the metal platens that you use. In this case, we were making MDF. In this case, I believe, and so when we made the MDF, you can see here on the left we didn't use release agent. So release agent is used to prevent the MDI from sticking to the metal platen. So the release agent can be quite costly. At least it was a long time ago when I worked in industry, which is about 13 years ago. I can't believe it's been that long. So you can see when we don't put release agent and we don't have any soy, there's a lot of sticking there to the platen. And then as you start to add soy at 10 and then 20%, you can see there's a lot less sticking. So it helps to mitigate and interrupt the bonding between the MDI and the soy. And so we're hoping that this could be a benefit in terms of the cost release possibilities for these composites. We've also looked at hardwood veneer. So the hardwood veneer, this one we've looked at different species here. You can see red gum through poplar, and we've looked at different spread rates. So the thing about the spread rates is that you have to find something that's cost effective, and so we haven't really found anything for that yet, but we're willing to continue to look at it in terms of the decorative hardwood veneer. So one of the things that we found some preliminary evidence is that the soy helps to prevent bleed through. So if this was cost effective, the MDI it's so low molecular weight, it likes to bleed through the veneers. And so the soy helps to prevent that bleed through. At least that's what we think. But I put inconclusive because at a small scale, we have a spread out of the glue out of the edges, and it comes back over the veneers. And so we get into a healthy debate in the lab about whether we're seeing squeeze out and overlapping, or if it's really not bleeding through. But despite all of that, we found that if we pre-press at 95 degrees C, we can pre-cure the resin and raise its viscosity and eliminate this bleed through. I put these grams per square meter in burgundy because when I first saw this 25 and 25, it looked like a typo, like it should be 20, 25, and 30, but this is correct. It's 25% soy at two different spread rates, like I mentioned in the previous slide. So only one failure occurred when if you pass the delamination, if only 15% of the pieces after the third cycle. And so you can see that this barely failed. And so it looks like you could easily dial in the right coverage. Cost is, of course, going to be the limiting factor probably, but you can dial it in to make sure that at least from a quality perspective, it passes. This is supposed to mimic LVL, laminated veneer lumber, but I need to point out that this is technically not laminated veneer lumber because these are very thin strips of wood that we made in the lab. So it's laminated veneers, but it should be called laminated veneer mini lumber or something, or whatever you would call it. But we were trying to mimic, the laminated veneer lumber just to see if in the lab that we can do it, because we don't have the testing capability to do large pieces in the lab. So just comparing it to a control. And we found that we can definitely substitute up to 20% soy flour into the MDI. Now the manufacturer uses a cold press. And so we've, if you noticed on the previous slide, we talked about we were able to pre-cure the MDI. And so, we think that we could make it work for LVL in the cold press. Moving on to orient strand board. This shows the edge swell and the water absorption. And we've also gotten much data on thickness swell, and it shows that, and these were statistically, this 15% is statistically lower than the 32%. And then this right here, I can't remember if it was statistically low or not, but we have found that somewhere between 15 and 20%, we can statistically reduce the edge swell and the thickness swell. And this has been consistent over many, many studies. So this is data from just one study. And so this was back when we were working on orient strand board. This was exciting and sort of surprising because the soy flour does not have an affinity or a like for water in wood composites, and so that's been its limiting factor. But by pre-mixing it with the MDI and being able to have the MDI, encapsulate the soy as it's in the composite, then when it cross-links, the soy is tied up with the MDI, and it actually improves the moisture resistance, which I think is very interesting because MDI itself is known to be very moisture resistant. And so to be able to add a biological, something biological to MDI, which is very superior to other adhesives, then I think that was something that's a value worth mentioning. This is very, very preliminary data on particle board. It's so preliminary. We just got this data this week. We've done some previous work on particle board, and so this is. I want to point that out because this is. Well, first of all, these are each of these averages are three 3 samples, and so they're not statistically different from each other, but they're only 3 samples each, so you need to take that into consideration. When we've done more work in the lab, though, we've found consistently that the soy flour is statistically equal to the MDI for dry and wet properties for the most part. Maybe in the wet properties, sometimes we see a slight decrease in the mechanical properties, and so we'd have to do more work to tease that out. But for the most part, it seems like you can substitute, and we show here the exciting things. You can substitute up to 30%. You can see the values there are not much different than the previous loadings. What we also found with soy flour is that we can go up. We can actually spray in the lab. Now, keeping in mind that's not the same thing as spraying in a manufacturing plant, but we take this sprayer from Lowe's and paint sprayer that you use to spray paint, and we use that to spray. And when we mix things like wood flour and other biological based materials, usually around 10%, the viscosity starts to thicken, and we're not able to spray. But with the soy flour, we're able to get up to 30%, and substitution is still spray in the lab. So in summary, and a couple more slides after this, but we've had 2 successful mill trials in the MDF plant, and we've had other lab trials at other industries, OSB, and we've worked with several OSB industries, and we're currently working with a veneer type company that works on the softwood end of things. And so we've seen successful results at various parts of the research pipeline. I know when I worked in industry, we had, you had a stage gate process. And so I would say our MDF has shot forward to sort of close to the commercialization phase, while our OSB is still a little bit earlier, even though we've been working longer on it to try to get that commercialized. So as I mentioned earlier, the soy MDI resin really works. It helps to improve the resin bleed through, and also the LVL looks promising, and we're working with the manufacturer with that. And we're thinking that what we're finding with LVL could be applied to glue laminated timber. So, if there was a glue laminated timber person out there, we would be excited to talk with you, and we're planning on approaching some companies when we get some more data on that. So in terms of the core finding, we know that MDI is superior to other wood resins because it binds directly with wood. And that's about all I'm going to say, because when I get into the literature, I see a fist fight going on about how MDI bonds with wood, whether exactly how well it does that. Once you start talking about the steam and the wood composites reacting with the MDI, people get into disagreements over that. And I'm definitely not the expert on that, so that's going to be my out on that argument. But soy flour does seem to increase the degree of MDI penetration into wood. And it also seems to help spreading out the MDI at the same time. And so we think that helps to explain also why we're seeing improved properties when sometimes you might think the properties should decrease. Once we get above 25%, and sometimes some products is 20%, some products is 30%. And so it really depends on the product and the flake size and how we apply it. But roughly between 20-25% is usually where your wet property starts to turn the bow of the boat, so to speak. We feel like we've sort of completed our fundamental work on our resin development, and now we're trying to, as you can see in this presentation, we're trying to find various applications from particle all the way up to veneers to see how we can apply this thing in a cost-effective manner. So our conclusions is that our soy reduces the resin cost by 2/3, and we also have found in almost all cases the MDI results in improved wet and dry properties. If it didn't improve it, it's statistically equal. We've performed full-scale mill trials, and we've been able to reduce the metal platen sticking, which hopefully could reduce the cost of the release agent. So I'd like to acknowledge the folks that have funded this. United Soybean Board has funded most of this work, but I don't want to leave out the alpha farmers. They provide a lot of seed funding, and so what we'll do quite often is we'll get some very important funding from alpha, our Alabama farmers, and then when we'll do some preliminary work, and then if it works in the lab, then we'll go to the United Soybean Board with the preliminary data and asked for more money to do a more comprehensive study that could then help us reach out to the company of interest. And we're also working with the Forest Service. We've got some funds with them to do CLT research, and so we plan on leveraging those funds also to see if we can connect to the CLT industry. So with that, that's the end of my presentation, and I'm open for questions.
Okay. We've got a few that have been typed into the chat box, and I've got a couple that Justin Price has emailed us too. And then certainly if anybody has any questions, you're welcome to turn on your video or your mic when we finish these and ask them directly to Brian. So let me jump right in, Brian.
Let me ask a question. Should I leave the presentation up so that I can go back and forth if people have questions, or should I get out of these?
I think it'd be fine to leave it up if you want to reference some of the slides based on the questions. It'd be fine. The first one from Leandro is, what were the main challenges to adapt the machines of the industry to the new formulation using soy?
So I would say that the main challenge that we found over the 5+ years we've been working is mixing. So what we find is we get over here and we mix and we figure out how to mix and get it to disperse, but then the moisture properties decrease. So we get over here and we figure out how to mix it and disperse so that the moisture properties improve, but then it's not quite homogeneous. And so that balance between figuring out how to mix, and what we did was we were able to heat it to 40 degrees C. You premix the soy flour, and well, this is one of the ways we've been able to do it for OSB, for example. We can mix the soy flour at 40 degrees C, and we find that the spraying actually is equivalent at 40 degrees C with soy that MDI is at room temperature. We actually, a couple years ago, we did a spraying study where we sprayed on a piece of paper, and we measured the distribution of the spot size diameter, and somewhere around 20%, 15 to 20%, we found that the spot size distribution starts to change around then. And so, but before that, the spot size was consistent to MDI. And so, and that was, one study that we did a while back. So that has been sort of the thing that's helped us to avoid having expensive capital expenditure so far.
That answer your question, Leandro?
Yes, thank you. Thank you very much.
Thanks, Leandro.
Yeah. All right, our next question, Brian, says, did you achieve PS1 properties for exterior grade or just properties for interior applications?
So the evidence shows that we can perform better than MDI, so we more or less compare it to the control. So I'd say the answer is yes, it does work for exterior grades. And yes, we do look at PS1 standards, but we tend to focus more on looking and comparing to the control, and consistently our moisture properties improve when we compare to the MDI control. And when you do a better job of mixing, a really good job of mixing, you at least for OSB, for example, we always see improvements in the moisture resistance. I like to point that out because when we first started this work and we were trying to mix and dump it very carefully, we would get mixed results. It'd be statistically equal to this study, and then the moisture, it would improve the next study. And so we concluded that it wasn't really improving. But then once we found that if we were very careful about how we mix, and we've also found that when we mix, if you mix too slow, it doesn't disperse. And if you mix too fast, you get these CO2 bubbles that release. And so you have to have that sweet spot when you're mixing to make sure that it's working appropriately. So yes, I guess I answered a little bit more than the question you asked. Is yes, we considered PS1, but we focus more on the controls.
Great. The next one, are the soy proteins from the soy flour mainly responsible for the cross-linking? And have you tried different soy suppliers to check for differences?
We haven't looked at many soy suppliers. So we think that the protein, yes, the protein is what's causing it. We've compared it to wood, for example, that didn't have protein, and it works better than wood flour, for example, works a lot better actually. So by that hypothesis, we think that the protein is helping, but we haven't actually dug in there and proven that smoking gun, I guess. And so that answers the protein part. What was the second question?
I think you answered it too, but have you tried different soy suppliers to check for different?
Yeah, right. Yeah. So I did. We have not looked at different soy suppliers, and we would be more than happy to talk to any soy supplier that's interested in working with us.
Okay.
So please, please send me a note somehow, and I'll be glad to talk to you about that, and would be glad to look at it. We have looked at toasted soy versus regular soy, and so we've looked at different soy types, but we haven't looked between suppliers.
Okay. What is the final solid content and viscosity of the core PB resin?
That's a good question. So the viscosity is if we heat it up to 40 degrees C at around 20% soy flour, this is, for example, the viscosity is equivalent to MDI at room temperature. So I don't know if that's exactly answers your question, but so did that answer somebody's question? I guess they'd have to.
That question was from Bruno. Certainly open it up if you'd like to add to that, Bruno.
Yeah, it's okay. Probably with the 40 Celsius degree, the viscosity will be normally for MDI is similar to water. When you heat to 40 Celsius degree, then probably with 20% of soy may be in the range like a normal or standard UF resin, I think.
Yes, that's we were able to reach soy viscosities equivalent to UF resin. So we did one study where we were actually looking at TAC, and we compared the soy to MDI mixture to a UF resin, and we found that somewhere between 15 and 20% substitution of soy, the viscosity or the TAC at least was similar to the UF. And so we found that in that case, I'm talking more about adjusting TAC, but we found that we could manipulate the viscosity for the UF if we needed to. At least that's my memory. But if we were to do some sort of study, we probably would want to go back and double check that.
Okay, thank you very much.
Okay. I don't know if you can answer this one, Brian, but what is the price for PMDI? Okay,
so people like not to tell me that price. So I guess I guess I don't know, but when I look into the literature and not talking with any companies, it seems like it's over $1 a pound right now. So yeah, that gets to be a very touchy subject. People don't want to tell me that, and when they do tell me, they probably inflate it. So I don't know the answer to that question, but I do know that people consistently seem to say that it's 2/3 more. So people, when I talk with different people and I test different ways, I seem to get a similar ratio, and so I sort of feel like we're in the ballpark.
But going back to your original comments of the things you're looking for were quality improvement or cost reduction, I mean, that was one of the intents of the work, right? To see if you could bring those costs down.
Right. Well, it depends on the company or the customer, and whether it depends on the situation. For a commodity product, they're very interested in cost reduction. In some cases, though, if you take a particle board and, for example, and maybe it's harder to use MDI for particle board because of the TAC issue, by being able to add the soy flour, it improves the TAC. So in that case, it improves the ability of MDI to be used in that product line. So it really depends on the application and the situation, whether it's cost or whether it's value added. But one thing that I can say that has been very helpful is when we first started this project, we would be statistically equal in our moisture resistance. And so, but then people were hesitant to pull the trigger because, statistically in the lab, you're looking at 30 samples or whatever, but in a plant, you've got, thousands to millions even over time, panels that are being made. And so you need to really know whether it's going up or down. So the fact that we were able to get statistical improvement or moisture resistance and getting that value addition improved actually convinces people that the cost reduction is there without a penalty to their process. So the value addition can go hand in hand with the cost reduction in convincing people that it's valuable.
Okay, great. We get a few more. Did the MDF trail improve percentage LE performance? I don't know if that should have been trail or trial. But did the MDF trial improve percentage LE performance?
I don't know about the linear expansion performance on that. So, yeah, I don't think I know and can tell anyway. But in the lab, we've seen statistical equivalence for MDF, if my memory serves correct, on linear expansion.
Okay. Next one from Will. What any advantages to cleanup to delivering mixing stations of resins, since there has been improvements in releasing on the platens after pressing?
So I would think that there would be improvements, but I don't know how you test that in the lab. So I think that would be discovered by the plant over time. For example, when we run mill trials, we don't really see the effect of that improvement because they're using release agent, and it takes time to see the effect of that. So I don't know, but theoretically, I would think that it could help the cleanliness for sure. And it's a very clean system, so that's another. So yes, I think it would help the cleanliness, but I don't know that for sure.
Okay. Will, does that answer your question?
Sure, sounds like another advantage.
And Sudip has his hand raised.
Okay. Sudip, you want to go ahead and ask a question?
Sure, Brian, a great presentation. Really enjoyed it. A couple of questions. One is regarding moisture in soy flour. Do you have any critical value that it needs to be below that? And what is the general pot life once you mix it?
Okay, moisture and pot life. So our moisture content we do as received, and when we test the moisture content of the soy, it's around 8% moisture. So it usually fluctuates, I guess, between 8 and 10% is what we've seen. And Will and George, you may remember differently, but they were actually in the lab when they were here, and recognizing this has no reflection on their company or anything like that. But if they want to mention because of that, so that's what I remember with the moisture, and then the pot life. So the pot life, that's a part we have to be careful, because if you can't mix it for 24 hours for sure. And so I think, what we found is that if you mix it within 30 minutes to an hour, then you can definitely, it's going to be okay. We think we may have found ways to extend that dramatically, but I can't really talk about that today for a few reasons. But based on just mixing and spreading, the idea would be to have an inline mixer and be able to mix and spray fairly quickly. And then one of the things that people in industry has had a concern about is well, would you get clogging? Because the MDI and the soy, could clog and clog up the exit during spraying. So that's one of those circular discussions. What I can say is that in the 5 years we've been working in the lab, we've never had our gun clog up. We do a lot of nanocellulose work with MDI, and we have our gun clog up almost every time. So that's something that we've seen. And then the other thing that we think with that is that, and what we've seen is that if you add, with the water that's in the soy, it helps to delay the reaction just enough to mix and spray. We think this anyway, based on what we're seeing. And so the reason I point that out is because we think that if you mix and spray and your line goes down, then we think that you can just flush the line out on the tail end with a little bit of MDI just to clear it out, and then that should prevent clogging. So I mentioned that because you asked the pot life question, and I had to go into defense a little bit, talking, how we have the solution for it, or the alternative, I guess, for that. So
Makes sense. Thank you.
All right, their questions are rolling in still, Brian, so we've got a few more. Is it a raw, whole soybean flour? What's the particle size distribution?
Oh, goodness. We have the particle size data. I don't remember. It comes as is, but it's a very homogeneous size. We get it straight from the supplier, and so we try to work that way because we know that the plant is operating that way. So I can get that. If someone would like to know that information, I can definitely get that.
It is about 100 microns or lower. I think it's around 50 to 200, something like that.
Okay, 50 to 100 microns. Like I said, George worked with me on this project the first 2 or 3 years.
Yeah, Hunter may remember something there too. Will, you may remember something?
Will, do you remember? Does that sound about right?
It's been a couple of years. I think George probably, that sounds about right.
Yeah, most under 100, I remember.
Okay.
It looks like he's, this guy then cannot hear. He asked in email.
Okay. So what's the next question? Thanks, George and Will.
Yep.
Okay.
Again, I don't know that how much you'll be able to answer this one, but any idea about the cost of soy grade that you have used?
The cost of the soy,
Mm-hmm.
it's around, well, it's still, my understanding is right now it's around 40 cents a pound. It typically runs 30 to 35 cents a pound. So 40 might be a little bit conservative. It might be lower than 40 cents a pound. That has been fluctuating greatly. If you get online and look around, the price of soy has been inflated during COVID-19 due to the supply chain issues, but MDI has also been inflated. So overall, it looks like the benefit's still there.
Okay. The next one's about PPE. What is the personal protection equipment used when working with PMDI? And I would add to it, does that differ with soy?
I mean, with the students, I don't think it's going to lower the safe. Well, I don't know if it's going to lower the safety hazard of PMDI. So I would assume that, that the same safety precautions that the OSB mills, for example, use, if other industries wanted to look at this, that would be something that would have to be looked at, and that could be a capital expenditure for some people, depending on your process, I guess.
Okay. Got one more here, and then I've got two from Justin. The last one from Gordon is, did you test neat PMDI board properties at cost equivalent soy replacement rates? So
you're asking if we've looked at phenol formaldehyde, and the answer is we have looked at phenol formaldehyde with soy substituted, and Will actually did his dissertation on that subject, and we were able to find that there it's more of a, and Will can jump in and tell me I don't know what I'm talking about because he's the PhD that did it, but my understanding is more with PF it was less reactive than it is with MDI. It's more of a substitution effect. Is that correct, Will?
That's correct. It affected the viscosity quite a bit, which affected some of the resin spreading properties more.
Okay. So Brian, I've gotten several from Justin. The first one was, what was done to overcome the resin spots on the MDF?
So better mixing. One thing I can say and one thing I can't say. So I can't say the second thing, but we found a different way of mixing. But the one thing I can say is that if we, in the plant during a pre-trial, they don't want to buy the equipment. And so it's important to mix it appropriately. And so coming from industry myself, I used to work in R&D, and when we would go to the plants, people at the plants, might roll their eyes at me. Oh, here comes the R&D guy. He doesn't know what he's doing. We know how to mix. So that sort of sets up the stage. We didn't want to look like we were telling people how to mix stuff, because that wouldn't go over very well in the mill. So we allowed a little bit of tolerance in for them to mix it themselves. And so I point that out because when you mix preliminary, it sounds like, well, this doesn't sound very practical if we got to go to all this trouble to mix something. But we know that the inline mixer will take care of that issue. But it's the chicken and the egg thing. The mill wants to see that it works, and then they'll buy the equipment necessary to mix it. And so anyway, I forgot really where I was headed with that, but hopefully that answered it.
Well, the next question continues with mixing. It says, when blending with inline mixers, were you using high shear mixers, helical static mixers, or wafer type? So
with the inline mixers, we haven't actually, what we've been doing is just in the lab. And so in the lab, we haven't been really doing inline mixing. We've been doing everything by hand and blending, and with very fancy lab level equipment. And so And so in the plant, the mixing they did was with a big giant, kitchen type stir, or whatever you call that, the blender kind of a thing, is a preliminary thing. So they had a big drill with a big long drill bit and was, looked like making a cake, kind of a spindle. And so that's what we were doing in the preliminary stages. So we haven't actually looked at the inline mixing yet, because in the lab we don't know how to replicate that. And so that's one of those things that we have to jump straight into the plant and try out.
Gotcha. Okay. Was there any concern for the mixing regarding shear of the mixture to cause the blend to break down or separate?
So once, the way I know how to answer that question, I think, is, and I don't know if this answers the question, but I mentioned earlier that, if you mix too slowly, it doesn't disperse well. And if you mix too fast, it actually causes these bubbles, these CO2 bubbles. And so the shear seems to have an importance, and you have to have that right rate of mixing to make sure in between that window, and so that you don't have issues. So I guess the answer is yes, it's important.
Okay. I've got 3 more questions. What's the MC of soybean flour used for replacing MDI?
So the moisture content, MC, I assume, means moisture content, and that has been around 8 to 10% every time we test it in the lab. So we get it straight from the soy flour supplier that way.
Okay. Okay, 2 more quickly, and these are both from Justin. What was the mesh size of the soy-based material, which you may have answered earlier?
Yeah, that 50 to 100 microns.
Right. Okay. And last one, was there a long-term storage issue of the powder soy, and was temperature of the soy reviewed, and would it have any effect on the final outcome?
Can you ask that again? I didn't quite.
Was there a long-term storage issue of the powder soy? So did you have any issues with long-term storage?
Let's talk about that first. And so there is no long-term issue, but you don't want to leave it sitting in your lab in the mill for 6 months or something. Let me just put it that way, because if moisture gets into it somehow, it can ferment. So but no, there's no issue. If you're going to use it like a regular manufacturing facility would use it, within a few weeks, it should be fine. And what was the second part of that question?
The second was temperature of the soy reviewed, and would it have any effect on the final outcome?
So when we mix the soy, we didn't vary the temperature of the soy, but we did review different MDI soy flour temperature mixtures, but that's after you mix the soy and then heat it to the right temperature. So we did not look at different temperatures going into the MDI, but so we have not looked at that, I guess.
Okay. So I just do kind of a last call for questions anymore in the text box, or if anyone would like to raise their hand or unmute and ask Brian a question.
As they said when I was in university.
37% de los sites de la Europa detrás de la cortina de hierro eran ya mega sites. Hoy día ese 37% ha variado y está del orden.
I don't know the answer to that question. So if somebody could please interpret that for me, I'd appreciate it.
Well, you don't know the answer, and I don't think we know what the question was. So I think I might have been an inadvertent question. So that wraps up the questions. We did have one more that said, "Is this presentation available?" You will get a link of a recording of the presentation for everyone that registered. So you can access that. It's placed on the Forest Products Society YouTube channel, but you'll get a direct link for it for the recording. It's also available on the FPS website to non-members via our internet store. So that will be available too if you have other folks that might be interested. On behalf of FPS, I'd like to thank Brian. I think it was a great presentation. I do a little plug for him. You should have recently received, if you're an FPS member, your issue of the Forest Products Journal. Brian's hard at work on issue 2 for this year. And it's a great publication. He does great work, and we'd like to thank him for that. Also, just a couple of FPS notes. Our international conference is scheduled to begin June 15th through the 17th. It'll actually be opening, what we're calling a soft opening, to allow you to view various presentations beginning June 1st. And then we'll have live technical discussions and some job fair activities those live days of June 15th through 17th. I think also of interest, we have recently announced the International Conference for Wood Adhesives has been moved to May 11th through 13th of 2022. And that'll be in Portland, Oregon. If you'd like more information on that, you can go to the FPS website. I think that gets us for housekeeping. So we'll thank Brian one more time. Certainly encourage you to learn more about FPS. If you're not a member, we'd love to have you. That'll conclude today's presentation. Brian, I've got one hand raised. Jennifer, it went away when we switched the view there, but I didn't see whose hand was raised. But I would just, if you do have a question, feel free to unmute and ask the question to Brian. Okay, not hearing anything. Jennifer's put up our next webinar will be Wednesday, July 21st, and that is with Justin Price at Evergreen Engineering. So you'll receive some more information on that one too. We'd love to have you join. So no other questions. That'll conclude today's session. Thank you all for joining us. Look for an email with the recording, and we'll look forward to seeing you next time. Thank you very much. Thanks, Brian. Great job.
Thanks. Great presentation.
Thanks, Will and George.
Okay, take